Hello, parents and any teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we'll look at how your grade 1 student may be learning about addition. In the overview video, or the introduction to addition video, I talked about the meaning of addition, that idea of putting things together and combining and joining, that the language of story problems that your child will be hearing about, acting out, modeling in some way. So we want to think about that language as an important part of this. If you see a problem as simple as 6 plus 4, that's how I would have always read it, 6 plus 4. But see, if we can start using that language when we see that plus sign, 6 put together with 4, 6 joined with 4, 6 combined with 4, you see, that helps children make the link between those symbols and the language and the story problems. So think about when you're working with your child using that language when you see the symbols, not just plus. Okay, now we also have certain strategies that your child will be developing, that they're introduced to in grade 1. One of the strategies I mentioned was bridge to 10. And in that intro video, you'll get a chance to see how bridge to 10 is actually the associative property. We'll look at that a bit here, but how that associative property can then be used going right up through the grades up into middle and building the foundation for the more general form of that property in middle and high school. We'll look at a doubling strategy and the models we use for that. And that will build the foundation for distributive property later, if we pick the right models. And then we'll look at counting up. So we have different materials you may see your child using in grade 1. Lots of different stuff, I guess I would say. And you have counters. Now in kindergarten, your kindergartner may get a chance to use animal counters and bear counters and vehicle counters, all beads, all different types of counters. They may also use these square tiles or clear counters or something as simple as spray painted lima beans. But in any case, we're using counters to help them model the problems, model the stories, but also model that computation and build those understandings behind the facts and the stories, that meaning of addition. You may also see unifix cubes. Now these connect in one way. We can break them apart, and it lets us look at tens and units a little bit different ways. So as I said, we break these apart. Great model that your child may use. They may also use a base 10 model. Notice these 10 rods and unit cubes. As they move up through the grades, they'll see 100, a 10 by 10 100 model, and 1,000 model. But in grade 1, more than likely, they'll be using base 10 rods and these unit cubes. Now, these can't be broken apart. So you may find that your child starts here because, as you see in the subtraction video, if I want to remove 9, I can break it apart. I don't have to trade in for individual pieces. It's a more efficient strategy. So we purposely pick materials to help build understanding and help build efficiency. Now, you also see some different types of dominoes. These are probably more familiar images for dominoes, right? Double 9 set of dominoes. You see these arrangements all the time. But also your child may be using 5-frame dominoes or 10-frame dominoes. And I'll show you how those are used and why they're important for developing the foundation for the strategies. Now, as I said, the meaning of addition, that's not my meaning. I learned a lot about that from the University of Wisconsin work on cognitively guided instruction. There's been a great deal of research on meaning of addition, and most of it is linked to the action, the joining, the combining. And what we want to do when we're working with your child is help them form an understanding of addition that will work for them going right up through grade 12 and into the university. So, for example, we probably will avoid telling your child that when you add, you'll get a larger answer. See, that won't be the case when they get into negative numbers. They won't add and get a larger answer, right? So thinking about combining like units, if we develop that understanding of addition, that will help them again with word problems, but it will also be a meaning of addition that they can use as they go up through the grades. Now, I mentioned bridge to 10 strategy, and I'll show you that strategy in a moment, but I want to first look at this form of dominoes. Now, if you notice, these 10 frame dominoes, if you find one of these numbers, let's see, there's an 8 here. Do you see that 8? And this 8? And this 8? See, the nice thing and the challenge with these dominoes, what makes them a little more challenging for your student, is not all 8s look the same. Here, when we use these dominoes, all the 5s look the same, all the 4s look the same. By changing the model a little bit, we add a little more challenge for your child. Now, the nice thing with this is I've got these 8s in the 10 frame, and notice what will be true about every single 8. There are going to be 2 blank spaces, so 8 is always 2 fewer than 10. Doesn't matter where they're located, 2 fewer. Now, at first, your child may just be working with matching activities where they match 8s with 8s and 1s with 1s. And they may be asked to defend how they know. So they may have to say, 8, 8, I made an 8. I know because 2 fewer than 10, or 5 and 3 is 8, or 4 and 4 is 8, or 3 and 4 and 1 is 8. They have to defend what they're doing. And that's one side of it. So recognizing quantity without having to count. You may hear the word subitize or subitize. Depending upon where you're from, it may be pronounced 2 different ways. But essentially, that's recognize quantity without counting. I don't have to count the individual pips to know that's an 8. I know this is a 1. I know this is a 7. I recognize it and I immediately know that. And you may be playing dice games with your children and getting them to recognize that that's a 6 or that's a 7 is helpful as we go through. Now, as I said, we can play a matching game, but eventually what we need to know are ways to make 10. And this model helps us build ways to make 10. Notice these 2 sections combine to make 10. How do I know I need a 2? Because there's 2 empty spaces there. I need 7 and 3. See, the model helps me decide what it is I'm going to need to put there. 7 and 3 is 10. I have 9. What am I going to need to make 10? The model helps me see the combinations. It helps free me up from having to count on to recognizing how many more are needed to make 10. So you may see your children spending time playing dominoes, but it's not just to play the dominoes, it's helping them start to build the imagery for ways to make 10, the combinations. Now that leads us to a strategy that is a bridge to 10 idea. So if I look at this particular model, I'm going to use my beans. It's an easy way for me to have 2 colors. And if you notice when I do this, how I am using color, especially teachers, if you're watching, the color use is purposeful. Now let's say I want to do 8 and 5, or let's do 9 and 6. Notice how I have one color on the inside and a different color on the outside. Now, if you hear the bridge to 10 strategy, It's using what we just did with the dominoes and filling, making a 10, and then the leftovers, right, represents a teen number. So I have 9 and 6, I fill it, same as 10 and 5. So again, 9 and 6, do it this way. Same as 10 and 5. Okay, so as we're looking, notice how I don't have just random colors in here, because I want it very clear what my start number was, what happened, how I changed it, how I combined to make the 10. It's purposeful. Think about how this image might be different had I chosen this material to use. See, for me, it's not mathematically incorrect, but it's a less clear image because I start to see all these part totals within the frame when I have all those colors in there. That's just how my brain works. And so I'm wanting it to be very clear. I had 9 and 6. Now, why this is important? See, when I move this one in, and it doesn't matter if I move this one in, I can move any of these beans in there to make 10. That doesn't matter. But essentially, what I'm doing is I'm thinking of this 6 right here. So I have the 9 plus 6, but I'm thinking of the 6 as 1 and 5. Right? I kind of split this off. So I've got 1 and 5. And the minute I move this in here, instead of associating the 1 with the 5, I associate the 1 with the 9. You see, your child may know that 9 and 6 is 15 immediately, and that's very helpful for them to know their facts. But what we're doing here is we're building the imagery for the associative property. So it's important that they spend time moving these. This isn't to replace them knowing with some automatic saying 15, that fluency. It's not replacing that, but they also need to build the imagery for the associative property, because that will help them as they move up through the grades, right? 9 and 6, same as 10 and 5, but this is what's going on with that imagery, associative property. When they get into second grade or later on in grade 1, they may start to see an image like this. Now, see, I could do the same idea. I'm just going to take it up into a teen number, right? I can do a teen number and how many more. So let's just take this one step further. I did 9 and 6. Let's do 19 and 6. You see, the idea doesn't change. Notice again, I'm using a single color for the 19, and then I'm actually putting a different color outside for the 6. Now, again, it doesn't matter which one of these that I'm thinking of, right? I could think of any of these to move in to fill that 10. But I've got 19 and 6, same as 20 and 5. That'll build right up. What's 99 and 6? Same as 100 plus 5. See, that bridging to 10 is very powerful. It'll let me bridge to 100. But even more importantly, I'm thinking again, when I'm doing 19 plus 6, put together with 6, combined with 6, if I'm reading it with that language, how was I thinking of that 6? I'm thinking of the 6 as 1 put together with 5. Instead of associating with the 1, I'm sorry, instead of associating with the 5, the 1 is associating with the 19. Okay, now I keep showing you with 19. What if I had said, sorry, 18 and 6. What's that the same as? 20 and 4. What if I had said 7 and 6? Oh, same as 20 and 3. This strategy, again, will work with whole numbers. The associative property will work with mixed numbers when they get into grade 4. It will work with decimal numbers as they move up into grade 5, grade 6, and beyond. So, associative property. You may hear it called bridge to 10 strategy, but I hope you see I can bridge to any decade. I can also bridge to a whole as we move up. It's a very efficient strategy because for some children, as they get into a problem like, 19 and 16, or let's even do 49 and 16 later, they may feel like they need to write this down. I would have when I was younger. I would have had to record this. I probably really would have written it like this. And I would have done some manipulation where I would have to rethink of 15 as a 10 and 5 ones. It would have been all procedural and there would have been a lot of writing. But if I know this strategy, what is 49 and 16 the same as? I have now taken something that would have been paper and pencil for me and turned it into a mental math problem. I picture what's going on here. I have that available for this associative property, but I know 50 and 15, 65, done. See, I can take, again, what would have been paper and pencil, mental, but we're building on these strategies, even for the children who know their facts. It's very important for them to spend some time with us. Now, the other strategy, that was bridge to 10. Another strategy you may see your child using is a doubling strategy. And these are 5 frames. Now, prior to the 5 frame use, or the doubling work, you may see your children doing some work with these 5 frames or other 5 frame dominoes. And they may start out with matching. These 5 frame dominoes only go to 5. These 5 frame dominoes go up to 9. Just like the 10 frame, there's all different versions, all different representations for 4, for 3 here. So they're looking at quantity and building flexibility, but we might be playing the same idea with 5 frame dominoes to make sure they recognize them. They might do combinations to make 5. So you may see your kindergarten child having done this because that's foundational for what we're going to do with doubling to work with the 5 frames. Now, teachers, if you're listening, one thing to think about is we don't want to think of the 5 frame as just something we use in kindergarten or pre-K. This is going to be a very important image for us with the doubling, as I started to show. Now, let's look at this doubling, double 5 frame. I'm going to show, let's do double 8. Or, no, let's do double 7 this time. Now, do you notice when I'm showing 7, I have 1 bean in each section, but I could show a 7 like I've done. I could show it up here. I could show it like this. See where I place these beans doesn't change the fact that 5 and 2 is 7. See, using the 5 frame, I'm doing the combinations of 5 and up to 10, those combinations that get me 5 and 1, 5 and 2, 5 and 3, 5 and 4. Now, in this case, I have double 7, and think about double 7 and the work they would have done with the 10 frame. Just even looking here, do you see how these two 5 frames come together to make a 10? Right? So we have double 7. I've got double 5 and double 2. Now that image is a very clean image, right? How did I think of double 7? I thought of it as double 5, right? Put together with double 2. Now I'm writing it this way, but this is foundational for what your children will be getting in grade 3. How do we think of double 7? As double 5 put together with double 2. How did we think of 7? Well, we thought of it as 5 put together with 2. See, this is the distributive property. Using this image is a very clear image for doubling, but it's also the imagery for the distributive property. So as I said with Bridge to 10, if your child knows their facts and they know double 7 is 14 and that they can do it very quickly, that's great, that's helpful. But this imagery is going to help us build what we need for distributive property as they move up through the grades. So it's important for them to work with that. Now, notice how I have single color here, but what if I want to do a double plus 1? If I know double 7 is 14, what's 7 and 8? Must be 15. What is going to be 7 and 9? Well, see, once I start getting with these strategies, well, I know that's the same as 6 and 10. I can slide one over and picture it that way. Or it's the double 7, 14, and 2 more, 16. So your child will be learning these doubles, partly because it gives us that foundation. If they're learning in this way, foundation for distributive property. It also lets them do some number theory, actually, because what happens with every double plus 1 happens to be an odd number. Every double plus 2 happens to be an even number. That general idea is very helpful as they move up through the grades and start to look at, excuse me, start to look at sequences that happen with odd numbers and sequences with even numbers. But this imagery will help with all of that. Now, let's stay with doubles, but I'm going to change the model a little bit. If I have double 2, see, once I get really comfortable with double 2, I know double 2 is 4, then I'll know double 20 is 40. See, it becomes about patterning again. Once your first grade child understands that, let's do double 4. If I know double 4 is 8, what's double 40 going to be? See, I can bridge, sorry for the noise, let me get these out. I can start bridging up to doubling decade numbers very quickly, but I want the imagery. I want very clear in their mind how different these quantities look. If I have double 4, I'm thinking in terms of units. If I have double 40, I'm thinking in terms of these units. Now, when I was a child, we would have been writing this vertically, and we wouldn't have been focused on units. We would have been focused on columns. 0 plus 0 is 0, 4 plus 4 is 8. You've got an answer. But foundationally, what we need them to understand for working with fractions and working with decimals later on, and even larger number, is what is the size of the unit that you're combining. You always combine tens with tens and ones with ones. And what would happen then is I don't have to align if I understand I'm combining like size pieces. I could write it anywhere on the page. That's why you're seeing a lot more of this written horizontally than always vertically. It's building that flexibility, but it's building the understanding of combining like size units. Now, if I can do the doubles like that, let's just think about if I know 2 plus 3 is 5, then I'm going to know that 20 plus 30, 2 tens plus 3 tens happens to be 5 tens or 50. See, I'm still focusing on the size of the units as I'm working with this. So we use what they do with ones in grade 1, and we get them very comfortable. And then by purposefully selecting certain materials, certain models, we can bridge them up to working with larger numbers, because it's all about patterns. It's not about columns. It's about size of the unit that they're working with. Now, I want to go back to the 10 frame and just think about early place value. That showed us one example, because that showed us the example of using the base 10 materials to look at the difference between the unit and a 10, ones and tens. But I want to go back to this 10 frame. We've looked at it in terms of 2 5s coming together to make the 10 when we doubled 7. We looked at this when we were using a bridge to 10 strategy. But I also want to just take a moment to think about early place value. One of the first steps your first grader may be making in terms of place value is teen numbers. They will be teen numbers. Now, if I'm using a single 10 frame, sorry, I'm looking for the double, to show 14 versus the double 10 frame to show 14. I can put 14 in here, nothing wrong with that. And if I picture me filling this frame and having 4 ones over here, I'm seeing 14 in relation to 20. How many fewer than 20 is it? I'll see it'll be 6 fewer. When I do 14 this way, I'm looking at it in relation to 10. It's 4 more than 10. I have 1 10 and 4 ones. That is expanded form for number. When I want to get to a number like 24, you'll see me using this model again. I'll fill in these frames and have 4 on the outside. What is 24? 2 10s and 4 ones. Again, early place value, we're building with this same model. It's not just about identifying a number in a location. It's about having the imagery for the quantity, an imagery that serves us for the strategies with addition. Now, one thing I do want to mention before we leave addition in grade 1 is I mentioned a count on strategy. And one thing to think about, if you have a kindergarten child or you've worked with your child and they know how to count, no problem. One of the things that you may find in grade 1 is we're spending some time with counting still. And you're like, but my child can count to 100. It's not about saying those number words in order. It's about the patterns that occur with counting. See, to count on, for me, you want them to count on 1, 2, or 3. And it's really helpful for a problem like this. See, when I was a child, I would have written this vertically. I would have combined 9 and 3, and we would have called it carrying the 1, right? It would have been very procedural. Versus I could have counted up 30, 31, 32 and been done. A mental strategy again. So this, though, this ability requires me to be able to count on with any starting number. When we're in subtraction, we count back with any starting number. So when we're going to want to make sure that your grade 1 student, your grade 1 child, can count forwards and backwards with from anywhere, but they understand the patterns of counting. Now, when your child's in kindergarten and pre-K, they do need to learn the number words for 1 to 10. Those are unique. We might have them counting objects. We'll do that in certain ways to build that idea of quantity. We'd have them counting teen numbers, because those are unique. And then we also have them counting the decade numbers. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? Those are unique, and they need to be comfortable counting them forward and backwards. But what's really important for them is they don't have to memorize all of the number words between 20 and 29. It's patterns, right? 21, 22. It's the same pattern as when you counted 1 to 9. I should be able to skip around and say 40, right? What's 20 to 29? What's 40 to 49? It's the same pattern. Where it's really tricky for many young children is to go from, say, 48 to 52. That's a hard transition. They'll do 48, 49, 50, and then you may hear your child say 60, 70, 80. They'll go into a different counting pattern. That's very common, but we're going to be working with your child to make sure they can do this with no problem going forward and backwards, because that's the counting on. That's this idea. Right? Counting on 3 from 29 means I need to know I go 29, 30, 31, 32. And that is challenging for some children. So if your children are spending time counting and you're thinking, oh, they did that in kindergarten, it's very much linked to a count on addition strategy that, again, will move problems that would have required paper and pencil for us to being able to do more mental strategies. Counting on 1, 2, 3. They might count on 10, 20, 30 as they keep going up through their grades, or 100, 200, 300. Or they may be asked to count by halves when they get into grade 4, right? All of these strategies are building more efficiency and are helping your children become more playful with number, okay? So if this video was helpful, I hope you will give it a thumbs up. Click the notifications bell so you'll know when other videos are available. Please subscribe. If you haven't had a chance to watch the introduction to addition video, that'll give you some more information about how these progress through the grades, these ideas. And if you have children in other grades, I hope you'll check out those videos. Thanks so much for watching.